You type in a website and you trust it takes you to the right place. But what if it didn't? What if the internet gave you the wrong answer? In 2016, a huge part of the internet went down. Twitter, Netflix, Reddit, GitHub, gone. Not because servers failed, not because of a hack, because of DNS. The system that tells your computer where anything on the internet is. And just like BGP, it runs on trust. If BGP decides where your data goes, DNS decides what you're asking for. And if that system breaks, you don't just lose connection, you lose meaning. Today, we're breaking down how that's even possible. Using the internet feels simple. You type a name, you get a website. Google.com, YouTube.com, Netflix.com. Names. Easy to remember. Easy to trust. But computers don't understand names. They understand numbers. Every device on the internet has an IP address, a numeric identifier. Something like 142.250.190.78. Not exactly user-friendly. So every time you type a domain name, something has to translate it. Turn it into a human-friendly name for a machine-friendly address. That system is DNS. Domain Name System. It's the internet's phone book. And like a phone book, it has a job. Look up the number when you need it. Except in this case, the number is an IP address, and the phone book is distributed across thousands of servers globally. When you type a domain into your browser, your computer doesn't know the answer. So it asks a resolver. This is usually run by your ISP or a public provider like Google or Cloudflare. That resolver's job is simple. Find the IP address. And it usually doesn't know either. So it starts asking questions. First stop, root servers. There are only 13 logical root servers globally, labelled A through M. They don't know the final answer. They don't know where to look next. They respond with ask the .com servers. Next stop, top level domain servers. They say ask the authoritative servers for this domain. Finally, the authoritative server responds. Here's the IP address. That answer travels back through every step until it reaches your computer. And only then does your browser know where to connect. All of that happens in milliseconds. It's one of the most elegant systems ever built. And like most elegant systems built on the internet, it works because everyone agrees to follow the rules. DNS looks decentralized, but it isn't entirely. At the top there's hierarchy, root servers, top-level domain authoritative servers. And overseeing the system, an organisation called ICANN, the Internet Corporation for Assigned Names and Numbers. They coordinate domain names globally, assign TLDs, maintain stability, which raises an uncomfortable question. If someone controls the root, how decentralized is the system really? It's not absolute control, but it's not complete freedom either. It's a balance, and like most systems built on balance, it works until something pushes it too far. The 13 root servers are operated by 12 different organizations, a distributed design meant to ensure redundancy. Each root server is actually a cluster of servers. The JRoot, operated by VeriSign, consists of hundreds of individual machines distributed globally. The FRoot, operated by Internet Systems Consortium, has over 150 server instances worldwide. This distribution is crucial. If all root servers were in one place, they'd all fail together. But distributed across the globe, with diverse operators, the system survives most failures. The only thing that could break the entire system would be something hitting DNS itself. And that's exactly what happened in October 2016. October 21, 2016, a company called DYN provided DNS services for a huge portion of the internet. Not direct access necessarily, but if your favourite website used DYN for DNS, DYN was the phone book they relied on. Then DYN got hit by a massive distributed denial of service attack. Millions of devices infected with malware called Mirai flooded DYN with traffic, tens of millions of requests per second, overwhelming their infrastructure. DYN status: first attack on 7:10 AM ET on the East Coast. The second wave hit the West Coast and Europe around midday. A third wave came in the evening. Each time they worked to mitigate, each time they restored service, but the damage was clear. While the attack raged, websites could not be found. Twitter, Netflix, Reddit, GitHub, Amazon, PayPal, all unreachable. And here's the terrifying part. The data still existed. The services were still running. Netflix's servers were online. Twitter's data centers were operating. But without DNS, no one could find them. Think about that for a second. It's like having a phone number that works perfectly, but the phone book is destroyed, so nobody can reach you. DYN restored service in approximately 2 hours, but the incident continued throughout the day. And after it was over 14,000 customers stopped using DYN as a provider. That's 8% of their customer base gone. Because people learned a hard lesson. DNS is a single point of failure. Here's the thing about distributed systems. They're only as reliable as their dependencies. Companies thought they were resilient. They used multiple cloud providers, multiple regions, multiple backup systems. But if all those systems use the same DNS provider and that provider goes down, everything goes down together. You can't bypass DNS. You need it to find anything on the internet. It's not like server outages where you can have backups. There's no alternative pathway. Either the DNS works or the entire system is inaccessible. The attack on DYN used a Mirai botnet, malware that infected hundreds of thousands of IoT devices like security cameras, routers, DVRs. Most of these devices had default passwords, weak security, no patching. Hackers weaponized them into an army, and that army was powerful enough to take down one of the internet's critical infrastructure providers. If you want to understand how fragile the internet really is, how it depends on systems most people have never heard of, hit subscribe. We break down infrastructure stories regularly. The dependencies we don't see, the vulnerabilities we don't think about. Drop a comment. Have you ever experienced a DNS outage? How did you even know what was wrong? Because most people don't understand DNS until it breaks. Back to the story. DNS has another weakness. It trusts responses. When a resolver gets an answer from a server, it assumes the answer is correct. And that opens the door to manipulation, DNS spoofing, cache poisoning. Attackers can inject false answers, send users to the wrong place, without them even knowing. You type in your bank and you get a site that looks identical. But it isn't. There are protections. DNSSEC adds cryptographic signatures to DNS responses, verifies that answers are genuine. It's elegant, it's secure, but adoption? Still not universal. As of 2024, DNSSEC is only operational in 45% of country code top-level domains. For .com and .net domains, the most common TLDs, adoption is only around 4 to 5%. Major domains like google.com, amazon.com, microsoft.com are still unsigned. Why? Because enabling DNSSEC requires coordination between domain owners, registrars, and DNS providers. It's complex, it's manual, it's expensive, so most people haven't bothered. And as more users rely on public resolvers, Google, Cloudflare, DNS becomes more centralized, more efficient, but also a bigger target. The internet feels simple. You type a name, you get a result. But underneath, the two systems are working together. BGP decides where data goes. DNS decides what you're asking for. And both run on trust. No central authority verifying everything. No single source of truth. Just systems agreeing with each other. Until they don't. When they fail, the internet doesn't just slow down. It stops making sense. You can't reach anything because you don't know where anything is. The servers are still there, the data still exists, but it's inaccessible. This is the internet we actually use. Not a single system, but layers of trust systems, each assuming the layer below works. And when one breaks, everything that depends on it breaks too. The question is, how long until the next one fails?